Well, hello there everyone. We are going to continue with our little adventure into fractions and what they mean, and looking at them in a picture way to help us work out what's going on with them. But before we do, let's have one of these. We know what we're doing with these by now, so pause it and see how far you can get, or do the whole thing and then compare with what I've done. So I'm reckoning that 16 adds to 20, and of course look out for my mistakes because it does happen. I think I got the last one right though. Those two add up to 57. 24 add 5 is 29. What do we add to 27 to get 48? Well, 21. 21 take 3 is 18. 18 add 9 makes 27. Those two add up to make 48 as well as that, and double 48, I know that one, is 96. Right, then add those two together. I like the look of doing that. 210. Should do this really, shouldn't I? Adding 30 to 27 would get me 57. Take 1 back gets me 56. And 21 add 29 is 50. 50 add 56 is 106, so that makes me think I've probably got that right. 213, if I add those ones together, add those two gets me 423. Add those two gets me 410, meaning at the very top I'm going to have 800, and 10 23 makes 33, so 833. And we're done. Now you may have noticed this little maze, so I'm not going to do this now, but if you do like a good maze, then that's where you start. If you wanted to print that off and have a go at that, by all means feel free. Right, let's start. We're going to have a little bit of a game of what's bigger and what's not, and we're going to do a bit of comparing fractions today, but also adding them. So because in order to say which is bigger, 2/3 or 3/5, and be really sure about it, the only way we can do it is to do something that you also have to do if you're going to add fractions. You can only add fractions if the size of the pieces is the same. Now, you might think with 2/3 or 3/5, there's different ways we could think about it. If you think about it as being circles, does that help us? I mean, 2/3, I reckon, is going to be about that, isn't it? So we're looking at about that much. And if we've got fifths, how do we do fifths? Normally I like to think of a stick man, but he's just got a line for a head as well, and something about like that. So 3/5 would be about that, and they look about the same, don't they? And that's just a very rough thing. So what could I do that would be more definitive than that? What could I do that uses the squares? Right, and this is what we're going to do. The most important defining feature of a fraction is the bottom number, what's called the denominator. And I'm sure you know that word denominator, but you might not know what it means. It basically means thing that says what type something is. A denomination is a type. And the top number, being called the numerator just means how many of something there are. So I've got 3 of the type fifths of fractions, and that means it's been cut into 5 equal bits. Right, let me show you how I would prove which is bigger, 2/3 or 3/5. You may have an idea, I don't know. What I'm going to do, because it's thirds and fifths that I'm comparing, I'm going to draw 2 rectangles that are 3 squares wide because of the thirds, and 5 squares long because of the fifths. So I'm going to do that, and I'm going to write or, and I'm going to draw another one exactamundo the same. Now, how could I shade in 2/3 of this? In fact, I'm going to put in 2 lines across there to show my 2/3. to show thirds. And for fifths, I can cut it into 5 equal bits by going down, because it's 5 squares across and 3 squares high. Now that I've done that, let's make it all really clear. You can do this as well, by the way, folks. It's a good idea. Even if I do say so myself, it was my idea. I'm going to do 2/3, and I'm going to make them look nice and definitive by not doing the ones that are next to each other. And then I'm also going to do my 3/5, 1/5, there's a 2/5, and there is a 3/5. Right, now what is the denominator which can compare them? Can anyone see another shape inside the rectangles that will help us? I'm hoping that you're saying squares to me, because if I now go down here, we have got 5 times 3 equals 15 squares there, and we've got 15 squares here. And how many squares have I got in my 2 pink thirds? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 15ths. And how many have I got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So 10 15ths is 1/15 bigger than 3/15. So I can say 2, and I can use mathematical symbols here. I can say 2/3 is bigger than this. Instead of this, by the way, is just a pinched equal sign. It means this side is greater than this side, bigger than 3/5. And I can say by how much? By 1/15. I can even go further and say, if I wanted to do 2/3 plus 3/5, I could say that that is equal to 10 15ths plus 9 15ths, which is 10 plus 9 is 19 15ths. Now, are we allowed to have a bigger number on the top? Well, we are, if it means we've got more than one whole. And we have got more than a whole, haven't we? Because we've got more than a half there and more than a half there. If I had 2 lots of pence and they were both more than 50 pence, overall I'd have more than £1. So we can then write this as what's called a mixed number. One whole is 15 15ths. So how many more than 15 have we got? 16, 17, 18, 19, that's 4. 1 and 4 15ths. So I hope we've learned a few things there. We can even think about what's happened here. Why is 2/3 equal to 10 15ths? Because we've multiplied them both by 5. But why does that work? Because when we're timesing by 5, what we're really doing to the bottom number is cutting all the pieces up 5 times smaller. And then what we're saying is to have the same amount, if I've got 5 times as many pieces and all smaller, I'm going to need 5 times as many of them to make that same amount, aren't I? And over here with 9 15ths, if I write my 3/5 here and put an arrow the other way, 3 times 3 is 9 and 3 times 5 is 15. So we've times the top and bottom by the other denominators, which you've probably been told before, but you might not have appreciated why. So we're going to practice a bit more of that now. Right, here's our follow-up question. Write this down. Which is bigger, a quarter or a third? You might think you know that if you cut things up into quarters. They're smaller than thirds, aren't they? Because there's 4 of them as opposed to 3, and they add up to the same thing. But then, what is a quarter plus a third? So I don't only want to know which is bigger, I want to know how much bigger a third is than a quarter. what are you going to do? You're going to draw two rectangles. What's the size of those rectangles going to be? Pause it and have a go. Right. Hopefully you're drawing rectangles that are 4 wide by 3 deep. It could be 3 wide by 4 deep. That doesn't matter. So we've got that, and we've got another one the same size. This third over here, I'm going to cut into thirds that way, and then this one I've got 4 columns that I can use. So how many squares have I got all together? Though we're only talking about 1/4 this time, aren't we? So it could be any of them. Yellow doesn't show up so well, does it? That's not so good. And 1/3. So I can see that it's 1 square more straight away, because I got 4 squares for a third and only 3 for a quarter. But how many squares have we got? And we've got, because it's 3 wide and 4 long, the area of a rectangle is 3 times 4. So 3 times 4 gives us our denominator. And I've got 1, 2, 3 there, so it's 3/12, and I've got 1, 2, 3, 4 there, so it's 4/12. So a third is 1/12 bigger than 1/4, and 1/4 plus 1/3 is equal to 3/12, because that's the same as a quarter, plus 4/12, because that's the same as a third. 3 plus 4 is 7, and the 12th stays as 12. If you add 12 and 12 and get 24, you're suddenly making the pieces a lot smaller. No, we've got the same size piece. 12ths is what we want. Right, let's have another one. This one's going to be a bit more. What is bigger, 2/5 or 3/8? And what is 2/5 add 3/8? Well, pause the video and start by drawing 2 rectangles. Hopefully your rectangles are 1, 2, 3, 4. I'm going to go 5 wide and then 8 down, because it doesn't take up as much space going across. 1, 2, 3, 4, 5, 6, 7, 8. And then let's go again. You might like to use a ruler for this, but as long as you keep your eye on it and you're close enough to the lines, you should be alright. So we want 2/5. That's that much, isn't it? And 3/8. That's that much. Right, how many squares have we got all together in one of our rectangles that is representing our whole? We've got 5 going across by 8 going down. So the area of that, the number of little squares making up the whole rectangle, is 5 times 8 is 40. So 2/5 is going to equal something over 40. Each fifth is made up of 1, 2, 3, 4, 5, 6, 7, 8 squares going down, isn't it? And it's 2/8. So I've done 5 times 8 to get 40, and I'm doing 2 times 8 to get 16, because I've got 16 squares in all of that. And over here, my 3/8 is going to become something else over 40. I've got 5, 10, 15. 3 times 5 is 15. So I've done 8 times 5, because that gives me the same as 5 times 8. And then I'm doing 3 times 5 to give me 15. Now that I've got that, I can say that 2/5 plus 3/8 is equal to 16 over 40 plus 15 over 40. and a 40th is a pretty tiny fraction of something. And what we've discovered here and proven is that 2/5 is exactly 1/40th bigger than 3/8. And that might surprise you. It surprised me, to be honest. That's giving us 31/40ths. Right, hopefully you're getting the hang of this by now, so write this one down, pause the video and give it a go. You're going to start by drawing two rectangles. What is the length? What is the width? Where are you going to look? Hopefully you're looking at the denominator. So this is 10 and this is 3. To keep it going nice across the page, I'm going to go 3 wide and 10 down, but you could have gone 10 across and 3 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And same again. 10 down and 3 across. And I'm looking at 7/10. 1, 2, 3, 4, 5, 6, 7/10 going all the way down there. Or 2/3. So one of them, if I colour these in, is going to look kind of long and thin. So there is 1/3, and I can't resist to leave the middle bit as the bit open there. Oh, I'm running out of green. So there's me green 2/3, and then I'm going to go for a pink 7/10. So remember, what we're doing here is making it so that our whole can be split into an amount that 10 goes into, and so does 3. And then we can start to look at all of a sudden making the pieces the same size. So we make them smaller so that they can be the same size. So we're looking at the squares. So we've got all together 3 across by 10 down is going to be 3, 6, 9. 3 times 10 is 30. So we're going to have 7/10 equaling something over 30. Well, if we've got 3 times as many pieces, the piece will, if the pieces are 3 times smaller than 10 times smaller. What have I done? No, 3 times smaller. Because I'm confusing myself now. Then we're going to need 3 times as many of them, because instead of each piece being 1 strip 3 wide, they're now 3 squares, aren't they? We're cutting them this way as well. So that is 21/30. Over here, our 2/3, we have cut up the pieces all 10 times. So although I'm writing 10 times there, they're actually 10 times smaller. So it's like we've divided the size of the piece by 10 times. So we're going to need 10 times as many of them, which is 20, which means that 2/3 is just 1/30th less than the 7/10. So now we can say that 7/10 is bigger than 2/3 by 1/30th, and we can say that 7/10 add 2/3 is the same thing as 21/30 plus 20/30, which means the size of piece we're dealing with is 30ths, but we have got 41 of them, and 41 is a lot, isn't it? So it's more than 30. How many more than 30? It's 11 more than 30. So what we end up with is 1 11/30. And that, folks, is all we've got time for today. Next time we're going to start looking at mixed numbers and top-heavy fractions like this and how we convert between them.